Have you ever wondered how your calculator knew how to do a linear regression equation from your scatter plot? Well, in today's lesson, we will just find out how the calculator knows how to find your parts for a linear regression equation. Okay, so that's exactly what we're going to do today is linear regression by formula. Okay, so we want to be able to calculate a regression equation for a given set of data. To do so, you have to have our handy-dandy formulas to do that, okay? So we're going to try to build the regression line, y prime equals a plus bx. So we have to be able to calculate a, b, and then r, which is going to be our correlation coefficient. You may remember that. You've had that in the past as well, okay? So we want to be careful in recognizing the different pieces and parts of these equations. Okay, so A has some sums and squares and so forth. Okay, so we need our A for our formula. B, same thing, sum of x, sum of y, sum of x times y. And then R even looks a little bit crazier to the point where we even have a square root involved. So in a way, this is going to be like solving a puzzle. See if you can find all the given parts, plug it in, and come up with the correct linear regression equation. Okay, so before I do that, there's a couple little questions at the top here. It says compute the value of the correlation coefficient. If significant, find the equation of the regression line. Okay, well, what is significant? Well, when we talk about a correlation coefficient, that's going to be your R equation. Okay, it's significant, okay, if -1 is less than R is less than 1. You might recall that the closer R is to plus or minus 1, the stronger the relationship. Okay, the stronger the relationship. Okay, so to do our calculation, I'm going to let you into a new place on your handy-dandy calculator. Okay, 2var stats is going to be your new friend. Okay, to get there from here, okay, we're going to hit stat. Then you go over to calc. And right there you'll see choice number 2 is going to be 2var stats. Okay, and if your data lives in L1 and L2, you're going to have to tie that in somehow, maybe an L1 comma or an L2, but you need to be able to tell the calculator what list you're referring to. Okay, so that 2var stats is going to be your new friend. All right, so at this point, you might want to just stop the video because I'm going to have you here in example 1 enter the number of absences into L1 and final grades into L2. So if you need to stop the video to do so, go for it. Okay. All right, welcome back. If you stop the video, now we will continue. Okay. To be able to fill in the formulas up there above in green, okay, the values that we need, okay, I've got already made a great big list, okay, so these are going to be our values. So if you do your 2var stats, okay, and you get that to come up and you look right straight down the list, so I go stat, calc, 2var stats, you've told it L1 and L2, okay, and then you get a whole bunch of information, okay. N in this particular problem should come out to be 7. Okay, you can find the sum of the x's right there is 57. Find the sum of the y's. Okay, it might not be right there at first, but if you scroll down, oh my goodness, look at all that stuff in there. So you scroll up and down to find all these missing parts. Okay, the sum of your y's should be 11. The sum of the xy's should be 3745. The sum of the x squareds is 579. And the sum of the y squareds is a larger number, 38,993. Okay, so the first thing we do is compute the R value. Okay, so we're going to calculate R. So we're going to follow right across from up here at the top. So start with N, 7, times the sum of the xy, which is 3,745. minus sum of x, sum y. So that's going to be 57 times 511. Okay, all over the square root of, okay, we do n times the sum of the x squared. So that would be a 7 times a 579. So you see, it's like a puzzle. You got to find all the missing pieces and plug it in there. Okay, and then, and really I should probably box this in. Okay, and then it's a minus 57 squared. Okay, and I'll close off that bracket. Then we go again, another bracket, 7 times 38,993 minus 511 squared. And we'll close that bracket, and that's all under the radical. All right, so being careful to enter, I'm going to do the top, then do the bottom, and come up with the values for you. So when you type in your calculator, negative 29/12 on the top, 3084.04, and I'm just going to give you a bunch of decimals to make sure it looks right. Okay, and again, if you want to stop the video and you try this to see what you get, go for it. Okay, final answer I get on this one is negative 0.944. Okay, and we usually say on this kind of a problem, we're going to round 3 decimal places. Okay, so then the question was, is this significant? And I would say yes, negative 0.94 is in between the negative 1 and 1, significant. So proceed. All right, so now we have to calculate the A and the B values, okay? Kind of like the blue, so let's start with A. And again, it's kind of a puzzle, filling in everything appropriately into that A equation. Okay, so it's gonna start out as 511 times 579. Okay, and I'm just pulling the values right from that first list that we made together. Okay, 57 times 3745. And then it's all over 7 times 579 minus 57 squared. Okay, and again, I'm going to go through and do top and bottom for you just so you can check your work if you're doing it on the calculator. So the top comes out 82,404 and the bottom is 804. So when you divide, A comes out to be 102.493. Okay? All right, so then we need to calculate our B value. Okay, what be the B value? All right, so again, formula up here at the top. So we start with n times xy, sum of xy. So 7 times 3745 minus 57 times 511. Those numbers sound kind of familiar. Then on the bottom, 7 times 579 minus 57 squared. And if you separate it top and bottom, negative 2912 is divided by 804. I'm sorry, typo. Typo, get out of here, buddy. Oh, maybe you'll let me. Okay, 804. And that comes out for B, negative 3.622. Okay, so what does all that mean? Well, now we have our equation. Linear regression equation will be y prime equals, okay, so now I'm up here at the top. I'm using that formula at the top. A starts at 102.493 plus negative 3.622x. That is your linear regression equation by hand. All right, now, so somewhere in the middle of that, I said, boy, these numbers feel kind of familiar. Well, if you notice, the top of R is the same as the top of B. So if you do a good job figuring out the top of R, you can just borrow it when you do B. Okay, also, the bottom number here, 804, felt familiar. Oh, well, that's because the bottom of A is the same as the bottom of B. So again, if you do a good job on your A calculation, you can just borrow it and bring it to the B. You have one less big thing to calculate. Okay, don't have to, it's just available. All right, let me throw you one more example here. All right, so if you want to pause the video, let's load your data into L1 and L2. Okay, all right, if you're back, okay, the values I have this time, N is 6, and again, I used 2 var stats to get these values. 153.8, 18.7, 682.77, 5,859.26, and then 80.67. All right, cool. All right, next up, we shall fill in to calculate the correlation coefficient, R. All right, so on the top for R, we should do a 6 times 682.77. In fact, you can stop the video and try this yourself if you want to, and then check it with mine. 153.8 times 18.7. And then that's all over the square root of, and I'll put a first bracket, 6 times 5,859.26 minus 153.8 squared. Close up the bracket and have a new one. 6 times 80.67 minus 18.7 squared. Close up that bracket. All right, so if you do top by itself, 1,220.56. The bottom by itself, 1,242.958346. You can read that on the calculator. Okay, we get 0.982 for the R value. Is it significant? Yes, that means keep going. All right, next up, A. All right, so we're going to start with 18.7 multiplied by 5859.26 minus 153.8 times 682.77. And I know I'm going kind of quick, so you may want to do a little of this and then play the video and so forth. So then we have a 6 times 5859.26 minus 153.8 squared. Okay. This is awesome. So we get 4,558.136 all over 11,501.12. And if you divide that, 0.396. That's A's value. Okay. Now for B, if you followed what I set up at this previous example, okay, we could go in here and we can take the top of R, okay, and divide by the bottom of A, which is this guy right here. So if you wish to do that little shortcut, you have 1,220 divided by 11,501.12. Your B value comes out 0.106. So then to wrap it up, you've got your linear regression equation, A, 0.396 plus 0.106x, and you've got it. So behind the scenes, Mr. Calculator knows how to handle all that stuff. Okay? Well, I wish you luck with your upcoming practice on these puzzles, and I hope that you can get them all correct. Best wishes.